We have another example on the board. Please notice that this time we have again complex number expressed in polar form. We have to raise this number to the 5th power and angle is expressed in radians. Again, we are going to use the following theorem to solve this problem. So we have the magnitude is 17.2. We have to raise this to the 5th power. So 17.2 to the 5th. And I have angle 5 times negative 1.3 radians. Okay, 17.2 to the 5th power is equal to 1.5 times 10 to the 6th, and angle of 5 times negative 1.3 is equal to negative 6.5 radians. Please notice that this angle is a little bit more than 1 revolution. What I mean by that, if you are going to draw the complex plane, your vector is going to be somewhere over here, okay, because my angle has the value 6.5 radians. Please notice that we don't need such a big value of angle. We just need the value, right, from the real axis to the phasor. Okay? So in order to get this value of my angle, I'm supposed to simply add 1 full revolution to my angle theta. Someone is going to say why we're supposed to add. Because my angle is negative. If you want to reduce this angle, you're supposed to simply add 2 pi in this case, but if your value of theta is much greater than 2 pi, you're supposed to simply use multiples of 2 pi, because if you are going to add the multiples of 2 pi to the angle theta, you are not going to change the value of your complex number. So this is allowed to do so. So that's why I can say that my answer is 1.5 times 10 to the 6th and angle of negative 0.216 radians. And this is the solution to my problem.